Hi viewers, welcome to my channel. This is Antony Vijay. Today we are going to see about introduction to data structures. So let's see the definition of data structures. Data structure is a way of organizing, storing and searching a data in an efficient manner. So there are three important things, that is organizing, storing, searching a data or element in an efficient manner, that is called as data structure. Examples of data structures are, we can say array, stack, queue, linked list, so on, okay, etc. you can say. So next we will be going to see about the real-time example of data structure. So when I talk about real-time example, first we will see about stack. So stack can be used as a forward and backward option in a web searches, forward and backward searching options in a web browser, and second one is mobile messages. Mobile messages are stored in a stack manner, and third real-time example is notifications from YouTube, messages, emails, that can also done by stack only. So notifications. So these are the real-time examples of stack. When I talk about queue data structure, it can be used for sending multiple messages to a person. So here, one message after another message, it will send to the recipient. Multiple messages. And queue can also be used for job scheduling process in operating system. Job scheduling. When I talk about job scheduling, usually job can be done by RAM, that is random access memory. It means one process after another process. This is what called as queue. Then when I talk about graph, graph is also a data structure. It can also be used for finding out the shortest distance from one place to another place, and it can be used in Google Maps. So finding shortest path. Finding shortest path. So next data structure is tree data structure. So usually tree can be used in computer files, or you can say mobile files. Especially when I talk about computer, files are managed by tree data structure only. For example, if I consider about C partition, C is a partition, so it can have lot of folders like this. For example, the first folder may be program files and users, then Windows files, then Python files. Likewise, all the folders are arranged in a tree manner. So this is what called as tree data structure. So this data structure can be used for file management purpose. So these are the real-time examples of all the data structures. So next we will be going to see about the classification of data structure. So classification of data structure. So a data structure can be divided into two types, that is primitive type, the other one is non-primitive. Under primitive, we will be having some of the predefined types are integer, float, character, double, long. So these are the data structures we have already seen in C programming. Now we will be going to see about non-primitive data structure. When I talk about non-primitive data structure, it can be divided into two parts. One is linear, the other one is non-linear. When I talk about linear, the elements are arranged in a sequential order, but in non-linear, the elements are not arranged in a sequential order. So here, this linear can be divided into two parts. One is static, the other one is dynamic. So under static, we will be having only one data structure, that is array. So in dynamic category, we will be having three different data structures. The first one is linked list, stack, and queue. So these three things comes under dynamic category. And when I talk about non-linear, it will be having two different data structures, that is graph. The second one is tree. So this is what classification of data structure. So here we will be discussing about the basics of non-primitive data structures. Let's see about one by one. Now we will start with the array concept. Okay. So array is a collection of similar elements. Similar element means it may be float or integer or double. If it is float array, all the elements supposed to be float. If it is integer array, all the elements supposed to be integer. This is what called as array. Here all the values are arranged based on indexing. So indexing is very, very important. So index value always starts with 0. For example, here we are having some numbers 10, 20, 30, 40, 50. When I talk about array, all the elements are indexed properly. For example, here I can take one variable a. A of 0 means 10. A of 1 means 20. So likewise, A of 2, 30. A of 3, 40. A of 4, 50. Likewise, all the elements are indexed properly. At the same time, it is sequential. So in order to find the third element, you make use of A of 2. This is the way we make use of array. So next we will be going to see about linked list. So linked list is also a linear data structure. Here the elements are arranged in a sequential order, but it is stored in a not sequential. Not sequential means not contiguous memory. For example, I just compare this concept with array. So I just mentioned linked list versus array. I am having 5 elements 10, 20, 30, 40, 50. So same elements I am representing in array also. Same 10, 20, 30, 40, 50. When I talk about memory location, linked list will have some random location like 1000, 2000, 3000, 4000. So actually these memory locations are generated only by the computer, not by the human. Just for namesake I am giving here 1000, 2000, 3000, 4000, 5000. So in linked list, as I told already, there is a huge gap, 1000 to 2000 is a huge gap between every element. So here 1000 for 10, 2000 for 20, 3000 for 30, 4000 for 40 and 5000 for 50. This is what the address generally happening. So there is a huge gap between every elements. But when I talk about array, for example, if my starting address is 1000, it will be 1004, it will be 1008, it will be 1012 and 1016. Because 4 means what? It's the size of integer. So size of integer is 4 bytes. 4 bytes. So here the elements are stored in a sequential order, but in linked list elements are not stored in a sequential order, that is non-contiguous. Okay, this is what the difference between linked list and array. And at the same time, in array the sizes are fixed. For example, if I mention 5, a of 5 means we can have only 10, 20, 30, 40, 50. We cannot have the sixth element. If I add the sixth element, what will happen? It will throw an error. The name of the error is array index out of bounds. But in linked list, it's not like that. It is unlimited. We can have lot of elements. There are 3 different types of linked list. First one is single linked list. Second one is double linked list. Third one is circular linked list. So for example purpose, I just tell you about the single linked list concept. So when I talk about single linked list concept, so I am taking one node. A node can have 2 blocks. So these blocks can vary from one type to another type, keep in mind. So for single linked list, we can have one node can have 2 blocks. One node, this is whole part is called as node. A node can have 2 blocks. This is block 1. This is block 2. Block 1 have value. Block 1 have value of the element. Block 1 have value of the element. Block 2 have address of next node. Okay, so this is what called as single linked list. I just going to explain with a small example. So I am taking 3 nodes. This is the first node. This is the second node. Third node. Okay. So the address for the first node is 1000. And address for the second node is 2000 and the address for third node is 3000. So as I told already, first block belongs to value. So it may be whatever data type we can mention. So here I am giving 10, here I am giving 20 and here I am giving 30. So the second block is very important block. This block is used to connect all the nodes. So here it will have address of the next node. So here what address we have to mention? It's supposed to have the address of the next node. So this is the next node. Address is what? 2000. So the question mark place we have to mention 2000. Once you mention 2000, this node and this node are connected each other. Next, let's see about the next node. So here, as I told already, the second block contains the address of the next node. Address of the next node is what? Here 3000. So 3000 supposed to be come here. So second node and third node are connected each other. When I talk about third node, no other nodes are connected with the third node. So we supposed to use null here. So right side of third node, no fourth node. So you have to replace the particular second block with the null. This is the concept of single linked list. But the same process will be repeated in double, but small changes. So we will see that in the upcoming sessions. Okay. So this is what linked list. So next we will be going to see about stack. Stack data structure. So stack is also a linear data structure. Here in stack it follows LIFO, that is last in first out discipline. Last in first out. So stack means what? Here files are arranged in a order of one after another. For example, first file, this is first file, this is second file, this is third file. In order to take the first file, we have to remove the third file first, then second file, then only we can make use of first file. This is what called stack. So here insertion and deletion can be take place at the top of the area. This is what the top of a stack. Insertion and deletion can be done on the top of the stack only. The name of the insertion operation is push off, and name of the deletion operation is pop off. So two operations are there. So this is what the example of stack. Okay, next we will be seeing about queue. So queue is also a data structure. It means a linear data structure. Here it will follow FIFO. FIFO means first in, first out. That is, you can say it as FCFS. First come, first serve. Those who are coming first, they will be served first. For example, okay, so for queue, this is the first person standing in the queue, then 2, 3, 4, 5. Here the insertion take place in the rear side. Okay. Deletion take place in the front side. Deletion means what? Once the service is over, we have to move out from the queue. This is what. So deletion can be done in the front area. Insertion can be done in the rear area. But in stack, insertion and deletion both on the top of the stack only. This is what the example of queue. So here there are two operations, as I told already, insertion and deletion. For insertion, the name of the operation is NQ. The name of the insertion operation is NQ and name of the deletion operation is DQ. Okay. This is what the important points of queue. Okay. So next we will be seeing about non-linear data structure. It means the elements are not arranged in a sequential order. The examples of non-linear data structures are, we can say graph, tree and all. So graph and tree. So now we will be seeing about tree. So tree is a non-linear data structure. It means it is not in a sequential order. It is in a hierarchical order, one after another. For example, here the elements are called as nodes. So for example, here The first node is called as root node. For example, you can say A. So this A supposed to have two child, that is B and C. Root node also called as parent. A parent can have two child, child 1 and child 2. So B and C can have two child, D and E. So child 1 can also act as a parent. Child 2 can also act as a parent, F and G. So child 2 is also act as a parent. Here the topmost node is called as root and bottom node is called as leaf node. You can say leaf node or you can say external node. External means outside nodes. So like A, B, C and all, these nodes are called as internal nodes. Okay. So as I told already, this data structure is mainly used for file explorer purpose, mainly for searching a file concepts. Okay. This is what tree concept. So next we will be seeing about graph. Graph is also a non-linear data structure. Here a graph can have a combination of vertices and edges. For example, I am having a graph like this. Just have four vertices A, B, C, D. Okay, so these A, B, C, D and all called as vertices. These vertices are connected each other with the help of edges. Okay, so A to B, so AB, comma, then BD, then CD, then AC, or we can say AD also. AD. So these are called as edges. So a graph G is a combination of, you can mention in a curly brace, vertices, V for vertices and E for edges. This is what called as, this is a general form of a graph. A graph can have three different types. The first one is directed graph. Second one is undirected graph. And the third one is weighted graph. So this graph is called as undirected graph because there is no direction at all. So this type of graph is called as undirected. Then what about directed graph? If you mark like this, arrow mark A to B, A to C and A to D, then B to D, or you can see C to D. So if you mention arrow marks, that is called as directed graph. Then the third option is weighted. Weighted means what? We are giving some weight to the edges. For example, here I am giving weight for edge. In order to travel from A to B, we need a cost of 5. If I want to travel from B to D, I need 2 because this is very short. If I want to travel from A to D, I am giving 10 randomly. This is what random weighted numbers. This particular weighted graph is mainly for finding out the shortest distance. For example, if A is a source node and D is a destination node, in order to travel from A to D, we need to find the shortest path only in the weighted graph only. So this weighted graph is mainly used for traveling salesman problem. So this is the meaning for weighted graph. So guys, if you have any queries in this introduction to data structures concept, just mention in the comment box. At the same time, if you want to take any new topics, that also mention in the comment box. I will take in the upcoming session. Thank you very much for watching. Please like and subscribe to my channel and press the bell icon for regular updates. Thank you very much for watching.